You are all mostly welcome to my academic research channel. So in today's video, I will discuss some more GATE questions and its solution for doubly and triply students. And let us see the first question. This is 2010 and 12 and 11 questions. So the first question is a field excitation of 20 ampere in a certain alternator results in an armature current of 400 ampere in short circuit and a terminal voltage of 200 volt on open circuit. The magnitude of internal voltage drop within the machine at a load current of 200 ampere is 1 volt, 10 volt, 100 volt, 1000 volt. इसका मतलब देखिए क्वेश्चन में क्या हुआ कि for the same field excitation we are getting the 400 ampere the short circuit current and 2000 volt the open circuit voltage. इसका मतलब क्या है? So ये हमारा जो शॉर्ट सर्किट करंट ये शॉर्ट सर्किट कैरेक्टरिस्टिक्स है, तो इसका शॉर्ट सर्किट कैरेक्टरिस्टिक्स और शॉर्ट सर्किट टेस्ट करने के बाद हमको ये मिला एंड ये ओपन सर्किट टेस्ट करने के बाद हमको ये मिला। तो ये मतलब वी कैन डायरेक्टली गेटिंग द सिंक्रोनस इम्पीडेंस, that is the synchronous impedance ZS is equal to short open circuit voltage for a particular field current divided by short circuit. This is the this will be the open circuit. This will be open circuit voltage for a particular field current divided by short circuit for a current for the same field current. ये synchronous impedance हमको मिला. So that is a 2000 by 400, that is 5 ohm. Therefore we are easily getting the internal voltage drop, that is IZS. So internal voltage drop for 200 load current IZS is equal to 1000 volt. Therefore answer is D. So answer is D, that is 1000 volt. Let us see the next question. The unity step response of a unity feedback system with open loop transfer function Gs is equal to K by S plus 1 S plus 2 is shown in the figure. The value of K is this much. So here we have to find out what is the value of K. So here the open loop transfer function is given, then when we will apply unity step response which is shown in the figure. So this is the figure. So इसका मतलब ये हमारा आउटपुट है, ये आउटपुट होना चाहिए, मतलब we are applying unity step input. So this is 0.255, 0.75 and this is 1. But practically this is the response or output curve. This is the transient response and this is the steady state response. So the steady state response is not matches with our input, that is our reference input, unity step input. Therefore we are getting some steady state error because after transient period it matches with 0.75, but practically it must be um, 1, that is unity step. Therefore the steady state error occurs. Suppose ये जो response यहाँ से 100% मैच कर जाता तो यहाँ पे एरर 0 हो जाता, लेकिन ये तो मैच किया नहीं. तो 0.75 में उसका रिस्पॉन्स आया, therefore उसका एरर 1 minus 0.75, that is 0.25. So we are directly getting the steady state error. So now we can find out very easily what is the value of k. That is, we have to find out the steady state error using that open loop transfer function and put the steady state error 0.25. So let us see the solution. So this is the steady state error is equal to 1 minus 0.75 is equal to 0.25. So ES is equal to RS by 1 plus GSHS. This formula is already derived. So which is equal to 1 by S, that is the input is unit step input. The Laplace transform of 1, that is unit step, is 1 by S, then 1 plus K by S plus 1 into S plus 2. Then the steady state error we can find out by taking limit s tends to 0 s es, that is limit s tends to 0 s into es. Already we are getting this much, that is 1 by s 1 plus k by this much, which is equal to 0.25. Therefore if we will put to s is equal to 0 here, this s will be cancelled, and this is 1 and this is 2, and 1 plus k by 2. So 1 by 1 plus k by 2 is equal to 0.25. Therefore, by solving this, we can find out the value of k is equal to 6. Therefore, the answer is D, that is 6. So let us see the next question. Three generators are feeding a load of, sorry, this is answer is 6. The answer is 6. There is some mistake. Answer is D. D is the correct answer. So let us see the next question. Three generators are feeding a load of 100 megawatt. The details of generators are given. That is generator rating in megawatt, efficiency in percentage, regulation for unity on the 100 MVA base. So generator 1 is this is the rating. So ratings of all the generator are same. That is 100 here also 100. This is the efficiency, that is 20%, 30%, 40%. Then regulation 0.02, 0.04, 0.03. In the event of increased load power demand, which of the following will happen? That is generator 3 will share more power compared to generator 1. इसका मतलब क्या है? ये जो तीनों जनरेटर थे इधर, ये parallelly, they are connected in parallelly and feeding a load, of 100 megawatt. So ये तीनों जनरेटर मिलके 100 मेगावाट लोड फीड कर रहे हैं. तो सपोज उसका लोड डिमांड ज्यादा हो गया, मतलब बढ़ गया, उसके बाद कौन सा जनरेटर will share more power compared to other generator? This is very simple question. We should not calculate here anything. Directly we are getting the answer. कैसे देखिए, ये already we know that the generator जिसका रेगुलेशन ज्यादा है, सॉरी जिसका रेगुलेशन सबसे कम है, वो वाला जनरेटर ज्यादा पावर शेयर करेगा. मतलब it will take more load or more power, right? Therefore, therefore answer is C. The generator 1 will share more power compared to generator 2, and the answer is C because generator having better regulation share more power. Better regulation means उसका regulation कम होना चाहिए. So regulation मतलब regulation का मतलब जो fluctuation, that is voltage fluctuation from no load to full load. That is no load में कितना output voltage आता है. The load or disconnect load 100% full load देने से उसका वोल्टेज कितना फ्लक्चुएट होता है और इसी हिसाब से पावर कितना फ्लक्चुएट हो रहा है उसको बोलते हैं हम लोग रेगुलेशन. सो generator having better regulation can share more power. Therefore, generator 1 will share more power compared to generator 2. Either we can also say generator 2. Generator 2 also regulation is better than that is sorry generator 2 will share more compared to generator 3. ये तो आंसर तो ठीक नहीं है. तो generator 1 then generator 3 will share more power compared to generator 1. This is also not correct. Therefore, the answer is generator 1 will share more power compared to generator 2 because generator 1 का रेगुलेशन अच्छा है मतलब सबसे कम है. उसका फ्लक्चुएशन सबसे कम होता है इसलिए इट विल शेयर मोर पावर. Then distributed winding and short coding uh, employed in an AC machine will result increase in AMF and reduction in harmonic. This is also another very simple question. Already we know that all the practical machines are short pitch and short coding of it means short pitch winding or that is your uh, that is uh, fractional winding, short coding or short pitch, or we can say that is fractional winding and also distributed winding and sorry. Therefore, what is the main cause? उसका cause क्या है? हम लोग प्रैक्टिकल मशीन में जो लेते हैं उसको डिस्ट्रीब्यूटेड वाइंडिंग एंड शॉर्ट पिच और शॉर्ट कोडिंग और फ्रैक्शनल पिच वाइंडिंग देते हैं. Though we are getting EMF, the output is less compared to full pitch and concentrated winding. Still, we are given distributed and short coding winding because there is a large disadvantage of providing full pitch winding and concentrated winding. Therefore, though we are getting less EMF, but we are providing distributed winding and short coding winding mainly to reduce the uh, harmonic EMF so that the waveform we are getting a perfect sinusoidal waveform. Then the losses also decreases. So this is therefore the answer is D, that is reduction of both EMF and harmonics. That is reduction of both EMF and harmonics. So here there is some mistake. harmonics. That is reduction of both EMF and harmonics. This is the answer D is correct. So next question. Three single-phase transformers are connected to form a three-phase transformer bank. The transformers are connected in following manner. The transformers are connected. The transformer connections are represented by this. This is the connection, and this is the primary, and this is the secondary connection. Therefore, this is already we know that this is star connection. This is the star point or neutral point, and this is the delta connection. That is A1 to A1 to B2 and A2 to C1 and C2 to B1. This is the delta connection. Therefore, it is star delta, that is primary is star and secondary is delta with minus 30 degree phase displacement. Therefore, the answer is B, that is YT1. So next, this is there is some mistake. This is Y. Answer is B. It is YD1. Next question. The folding angle for eliminating fifth harmonic should be 30 degree, 34 degree, 36 degree, 35 degree. So answer is 36 degree. So folding angle, matlab already we know that we are providing short pitch winding or that is short folding winding. What is the main cause to eliminate the harmonic? So इधर दिया हुआ कि फिफ्थ हार्मोनिक जो हमारा थर्ड हार्मोनिक है, फिफ्थ हार्मोनिक है, सेवेंथ हार्मोनिक, ऑड हार्मोनिक, उसको निकालने के लिए कौन सा कोडिंग एंगल होना चाहिए, इसका मतलब अल्फा कितना होना चाहिए. So to eliminate the fifth harmonic, then what should be the coding angle? So answer is 36 degree. How it is possible? We can find out the solution. For fifth harmonic, the pitch factor Kp5 is equal to cos 5 alpha by 2, which is equal to cos 5 into 36 by 2. So here that is cos 90 is equal to 0. Therefore, the fifth harmonic component is totally becomes 0. So next question is 400 volt 50 hertz 30 HP three-phase induction motor drawing 50 ampere current at 0.8 power factor lagging. The stator and rotor couple losses are 1.5 kilowatt, 900 watt respectively. The friction and windage losses are 1050 watt and the core losses are 1200 watt. The air gap power of the motor. तो इसका मतलब हमको एयर गैप पावर निकालना है. ये दे दिया उसका 400 वोल्ट 50 हर्ट्ज 30 एचपी. ये उसका रेटिंग वोल्टेज एंड that is rated line to line voltage दे दिया. Then 50 हर्ट्ज फ्रीक्वेंसी उसका 30 एचपी जो पावर दे दिया, मतलब इनपुट पावर हमको दे दिया 30 एचपी. So three-phase induction motor, then it takes the 50 ampere current at 0.8 was rated current at 0.8 power factor. So इसके बाद रोटर कपल लॉस are also there. The friction and windage losses also given. So let us see the solution. The air gap power. So stator input power, already we know that input to the stator, that is root 3 VI cos phi. Then here V is 400 to I, that is I is also given, yeah, I is also given 50 ampere here. Yes, here I is also given 50 ampere. Therefore, here 400 into 50 into power factor, the cost by 0.8 into root 3, that is 27.71 kilowatt. उसका input power मिला. So air gap power, that is stator input minus stator copper loss minus core loss, that is stator core loss, that is 27.71 minus 1.5 minus 1.2, that is 25.01 kilowatt. Answer is C. So let us see. Yes, 25.01. Answer is C. Let us see the next question. It is desired to measure the parameter of 230 by 11, sorry, 115 volt, 25 kVA single phase transformer. The following wattmeters are available in the laboratory. That is W1 is this, and W2 is this, W3. The wattmeters used in open circuit and short circuit test of the transformer respectively. इसका मतलब ये हमको ये पैरामीटर मेजर करना है सिंगल फेज ट्रांसफार्मर में, दैट इज 230 वोल्ट और 115 वोल्ट, प्राइमरी एंड सेकेंडरी. ये हमका एलवी साइड है, ये हमका एचपी साइड है. सो 2 kVA ट्रांसफार्मर सिंगल फेज ट्रांसफार्मर दिया हुआ. सो हमको कौन सा वाट मीटर चूज करना पड़ेगा इसको मेजर करने के लिए. Therefore, let us see the solution. For open circuit test on LV side, rated voltage applied, that is 115 volt. So already you know that open circuit test LV side में क्या होता. So इसीलिए we have to apply the rated voltage, that is 115, and LV side current generally ओपन सर्किट सेकेंडरी साइड ओपन होता है, इसीलिए very it will draw very less current, that is 2 to 10% of the rated current. So let us see, let us take the 5%. Here given 2 to 10%, we will take 5% of rated current. So 5 by 100 into 2000 by 115, which is equal to 0.869 ampere. So since the power consumed is less, so power factor meter is used, that is your low power factor meter. क्योंकि ये सेकेंडरी साइड ओपन होता है, ओपन होने से उसका पावर very less, only it will take the power to fulfill the core loss of the transformer or iron loss of the transformer, because open the secondary side is ओपन होता है, इसीलिए उसको हम यहाँ पे हमको यूज करना पड़ेगा लो पावर फैक्टर मीटर. सो नेक्स्ट इज शॉर्ट सर्किट टेस्ट. शॉर्ट सर्किट test generally it is done in the high voltage side. So high voltage side हमारा इधर that is 230 volt. This is the high voltage side. So हमको इधर क्या करना पड़ेगा? देखिए, the short circuit test on HV side, the rated current is applied. That is 2000 by 230, 8.69 ampere, and applied voltage is 5 to 15% rated voltage. इसका मतलब क्या है? तो इसका मतलब जब हम 5 to 50% of the rated voltage apply करेंगे, we can get the rated current, that is 8.69 ampere, right? It means again I am telling, that is हमको रेटेड करंट पाने के लिए 5 से 15% रेटेड वोल्टेज अप्लाई करना पड़ेगा, क्योंकि जो सेकेंडरी साइड इधर शॉर्ट होता है, दिस इज द शॉर्ट सर्किट टेस्ट. इसीलिए as it is short circuited, therefore for small values of voltage we can get the rated current, that is only 5 to 15% rated voltage देने से हमको मिल जाएगा rated current. इसलिए here I have taken 10%. Here given 5 to 15%. Here I am taken 10% of rated voltage, that is 10 by 100 into 230, which is equal to 23 volt. But the power is high because we are getting the rated current. As the power is high, therefore here we are using um, that is HPF meter, that is high power factor meter. Also, therefore here W3, that is 150 volt 10 ampere HPF high power factor meter uh, is used. Therefore, answer is D, that is W2 and W3. So next question we will see, in a stepper motor, the detent torque means minimum of static torque with the phase winding excited, maximum of static torque with phase winding excited, and minimum of static torque, the phase winding is unexcited. The maximum of static torque with phase winding is not excited or unexcited. So answer is C, minimum of static torque, the phase winding is unexcited. So next question, an extra high voltage transmission line length of 300 kilometer can be approximated to lossless line having propagation constant beta is equal to 0.00127 radians per kilometer, then percentage ratio of line length to wavelength, that is 24.2%, 12.12%, 19.05%, 6.06%. So let us see the solution. So already we know that wavelength lambda is equal to 2 pi by beta. So which is equal to 2 pi by 0.00127, which is equal to 4947.39 kilometer. So ratio is equal to line length by wavelength. So line length already given 300 by wavelength already we have found, that is 4947.39, which is equal to 0.0606, and therefore percentage ratio is equal to 6.06%. So answer is D. So next question, disruptive corona begins with smooth cylindrical conductors in air at NTP if electric field at the conductor surface goes up to 21.1 kV RMS per centimeter, 21.1 kV peak per centimeter, then average per centimeter, then RMS per meter. So answer is the A, the correct answer, that is 21.1 kV RMS per centimeter. So thank you very much for watching this video, and please don't forget to subscribe this video if you like this question and solution. Thank you very much.